Okay, this is the next unit in Algebra 2. It's Unit 5. The unit is called Radical Functions, Equations, and Expressions. And this is Lesson 1. Lesson 1 is called Simplifying Radical Expressions. Okay? So just a quick summary on what roots and radical expressions are. Since 5 squared equals 25, 5 is a square root of 25. I think most people know that. Okay? Since 5 squared equals 25, 5 is a square root of 25. Since 5 cubed equals 125, 5 is called a cube root of 125. Okay? Since 5 to the fourth power equals 625, 5 is a fourth root of 625. And one more, since 5 to the fifth power equals 3,125, 5 is a fifth root of 3,125. I am going to stop there with those because I think I made my point. Okay. So the definition of an nth root for any real numbers a and b and any positive integer n. If a to the nth power equals b, then a is the nth root of b. Okay. That basically just summarizes what I said before. Look. 5 to the third power equals 125, so 5 is a cube root of 125. This is just explaining what I just went over. Okay? A little bit more terminology. A radical sign, which is right here. Okay, this is the radical sign. A radical sign is used to indicate a root. The number under the radical is called the radicand, which is labeled below. Okay, the number under the radical is called the radicand. And the index, which is labeled below. The index gives the degree of the root. Okay, if there's no index drawn, then it's implied to be a 2. Okay, think back to all the times you saw square roots. There was never a 2 right there. So if there's no number right there, then the index is implied to be a 2. Okay? So let's move on. Let's try example 1. I have 6 parts to example 1. Find each real number root. The cube root of -8. Okay? Basically what that means is what number times itself 3 times equals -8. Okay? What number times itself 3 times equals -8. If you know the answer, you can just put the answer. But if you think about it, this is the answer is -2. Okay, -2 times -2 times -2 equals -8. So the answer is -2. And here's why. Here's why. You can think about it like this: -8 equals -2 cubed. So the answer is -2. You don't have to write that first step. If you know the answer is -2, just put -2. So that's why. Okay, this question says find each real number root. We've done imaginary numbers, so you could simplify this with imaginary numbers, but we're not doing that. We're just focusing on real number roots. So for this one, I'm going to say there is no real number whose square is -100. There is no real number whose square is -100. The question just said find each real number root, so I'm not going to do imaginary numbers right now. Part C, the fourth root of 81. So what number times itself 4 times equals 81? If you know the answer is 3, just put the answer as 3. But here's why. 3 to the fourth power is 81. So that's why the answer is 3. You don't have to write that out. I'm just showing you. Okay. The answer is 3. 3 times 3 times 3 times 3 equals 81. Now for part B, there was no number that you can multiply by itself to get -100. But if the index is odd, then it is possible to have a negative for the radicand. Okay? If the index is odd, it is possible to have a negative for the radicand. Because if you think about it, -3 times -3 times -3 is -27. So negative 3 is the answer. And just to show you out each step, this is really negative 3 cubed. So that's why the answer is negative 3. Letter E, the fifth root of 32. So what number times itself 5 times equals 32? The answer is 2. Because 2 to the fifth power is 32. And part F, what number times itself 3 times equals negative 343? And the answer is negative 7, because negative 7 cubed is negative 343. So the answer is negative 7. Okay. The next page. Property. Nth root of a to the n for a is less than 0. For any negative real number a, the nth root of a to the n equals the absolute value of a when n is even. Okay. So here's what you need to know. So this is important. And you need this for the IXLs. When you're dealing with the variables, okay, when you're dealing with the variables, absolute value symbols are needed when, so absolute value symbols are needed when the index is even okay, absolute value symbols are needed when the index is even and the variable has odd degree. That's a little tricky. But if you think about it, the index can be odd. Okay, this has to do with having negatives. Okay, the index can be odd. You don't have to worry about any positives or negatives because you can take, you can have an odd index and have a negative radicand. Okay, so when the index is even, you have to worry about the variable having odd degree. If the variable has even degree, then it's always going to be positive because an even degree always becomes a positive number. But when the index is even and the variable has odd degree, you need to have absolute value symbols. Okay, so let's look at example 2. That's going to come into play in example 2. Okay, simplify each radical expression. Okay, you can think about this. I'm going to break it apart into the square root of 4 times the square root of x to the 6th power. The square root of 4 is 2. The square root of x to the 6th power is x to the 3rd power. Let me explain why, okay? X to the 3rd power times x to the 3rd power equals x to the, you add the exponents, and it gives you x to the 6th, okay? So the square root of x to the 6th is x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th, okay? So just one more example really quick. What's the square root of x to the 50th? That equals x to the 25th. One more. What's the square root of x to the 80th? That equals x to the 40th. And so on. Okay. So bottom line, the square root of x to the 6th is x to the 3rd power. Okay. But look above. Okay. Absolute value symbols are needed when the index is even. This index is even because it's a 2. It's not shown, but if there's no index, it's implied to be a 2. So this index is even. And the variable has odd degree. This variable has odd degree, so absolute value symbols are needed in the answer. Part B. Let's break it apart just to make it easy. We have the cube root of a cubed, and then we have the cube root of b to the 6th power. So basically, how many groups of 3 can you make if you have 3 A's? You make 1 group. How many groups of 3 can you make if you have 6 B's? You can make 2 groups of 3. So this is our answer. The question is, do we need absolute value symbols? Yes or no? Absolute value symbols are needed when the index is even. This index is odd, so it doesn't apply. I do not need absolute value symbols for this part. Part C. Again, I'm going to break this apart. I'll do the 4th root of x to the 4th. I like to do it like this. Some people don't. The 4th root of y to the 8th, and then the 4th root of z to the 12th. Focus on the x's. How many groups of 4 can you make if you have 4 x's? You can make 1 group of 4. How many groups of 4 can you make if you have 8 y's? You can make 2 groups. How many groups of 4 can you make if you have 12 z's? You can make 3 groups. Now let's go above. Do we need absolute value symbols? That's the question. Absolute value symbols are needed when the index is even, okay? Our index is even, it's 4, so we do need absolute value symbols here, okay? But we only need them around the variables with we only need them around the variables that have odd degree. So which variables have odd degree? The x does, because it's x to the first power. The y does not. The z does, because it's z to the third power. And you have to be careful. Whenever you have like more than one absolute value symbols, you have to combine those into one. You can only use one set of absolute value symbols in your final answer. So I'm going to put the y squared first, and I'm going to put all the absolute values in 1. Let me just jot that down so you know why I did that. Only use one set of absolute value symbols in your final answer. Only use one set of absolute value symbols in your final answer. Okay, this next one is going to be a little trickier. Okay, again, I'm going to break it apart by variable. So 5th root of x to the 7th, 5th root of y to the 10th, 5th root of z to the 14th. So the question is, how many groups of 5 can you make if you have 7 x's? You can only make 1 group, but we have some left over. I'll take care of that later. How many groups of 5 can you make if you have 10 y's? 2 groups. How many groups of 5 can you make if you have 14 z's? You can make 2 groups. And now we have some leftovers, so I'm going to put that under the radicand. So 5th root. Don't forget to put the index. We took out 5 x's, so we have 2 left over. We took out all our y's, so there's none left over. And we took out 10 z's because we took out 2 groups. That means there's 4 z's left over. Oops, I put y. Let me fix that. Okay, so that should be a z. And this is our final answer. Okay. Again, notice the way I put the answer. The radicand comes at the end. Okay, so don't put this first. The radicand comes at the end. We've talked about that a lot this year already. Okay, now the last page, the hardest page. Now the numbers are not perfect, okay? So you cannot take out, well, let me first do this, okay? Let me first separate it. So I'll do the cube root of 24. Then I'll do the cube root of a squared. Then I'll do the cube root of b to the 7th. You don't have to do that. Now, the cube root of 24 is not a nice number, but you can find, you can break it down. Think about it like this. 1 times 1 times 1, do this off to the side. Okay. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. I'm essentially taking perfect cube roots, okay? Perfect cube roots. Are any of these factors of 24? 8 is. So let me break it down like this. Kind of like when we do square roots. I'm going to break it down. I'm going to say 8 times 3. And now we can easily do the cube root of 8, which is 2. So take out a 2. How many groups of 3 can you make if you have 2 A's? You can't make any groups. How many groups of 3 can you make if you have 7 B's? You can make 2 groups of 3. So B squared comes out. And everything left over comes under the radicand. So let me put the index of 3. And what's left over? We still have that 3 left over because we took out the 8 and made it 2. The 3 is left over. We did not take out any A's, so we still have 2 A's left over. And we took out 6 B's, which means there's 1 B left over. Absolute value symbols are not needed because the index is odd. I don't think I mentioned it on example 2D, but no absolute value symbols were needed because the index was odd. Okay, let's try example 3B. Let me break it apart into the cube root of negative 250 times the cube root of x squared times the cube root of y to the 4th power. Think back to the perfect cubes I wrote before. I'm going to use 125. Okay? And you know what I'm going to do? I'm going to use negative 125. Now let's take out, what is the cube root of negative 125? What number times itself 3 times is negative 125? The answer is negative 5. You need groups of 3. You only have 2 x's, so that doesn't do you any good. But you have 4 y's, so you can take out one group of 3 from the y's. And everything left over goes under the radicand. So in this case, the 2 is left over. Both x's are left over. And 1 y is left over. You do not need any absolute value symbols because the index is odd. You only need absolute values if the index is even and your variable has odd degree at the end. Part C is talking about a 4th root. Let's think about 4th roots. 1 times a 1 times a 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. So 16 I'm going to use. I'm going to use 16 for this. Okay? Let me break it down like this. 4th root of 48. 4th root of x to the 4th. 4th root of y to the 7th. 4th root of z to the 5th. And then I'll break down 48 to 16 times 3. Now let's go. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. 3 is going to stay under the radicand. How many groups of 4 can you make if you have 4 x's? 1 group. How many groups of 4 can you make if you have 7 y's? 1 group. How many groups of 4 can you make if you have 5 z's? 1 group. Everything left over stays under the radicand. In this case, we have the 3 left over because we took out the 16, we made it 2. We have no x's left over. We took out 4 y's, so there's 3 y's left over. And there's one z left over. And remember, absolute value symbols are needed when the index is even and the variable has odd degree. So in my final answer, since the index was even, all my variables right here have odd degree, so they're all going to go in the absolute value symbols like that. And that's the final answer. That was a pretty tricky lesson, okay? So again, that lesson was called Simplifying Radical Expressions.